I work in the area of virtual reality, computer graphics, robotics, and more specifically in multimodal interaction, physically based animation and simulations, as well as robot motion planning and navigations, either in the physical world or in the virtual environment. And also applications. I have worked on many different applications, that including things that are related to medical, simulations, cancer screening, also urban computing. How do we support large, city scale planning, communications, navigations on the highway, and traffic management, and so on. I think the most exciting things about the area is that that I'm constantly working on problems that I feel that would have an impact on the society as a whole, and I think that's critical for me because I feel like I am hoping through research that I can make a bit of difference. I started working on, my thesis was on collision detections, which is essentially a process that's trying to determine if the objects have come into contact. And it's very much a geometric problem, but it's a critical geometric problem that happens everywhere. And a simple example would be like, if you have an autonomous car, you want to know when the car hits somebody or hit an object, right? And you actually want to try to avoid that. And to do that, you need to be able to have that particular computations to know how you can avoid collisions. So same thing with everything runs in the computer about the physical world. A lot of movies, animations that you see today, they are computer-generated effect that is essentially run on the simulations in the computer, and it does need to have this kind of analysis, knowing the relationship between different objects. So and also in surgical simulation, you need to know when the tools is cutting human tissues. You need to know when a mechanics is grasping an object and manipulate around in the virtual environment. And you need to know how is the real human working around in the virtual environment is interacting with the virtual environment for design, for prototyping, for manufacturing. And also, if you're trying to simulate a full society, you want to be able to simulate how human and human interact with each other physically, in the real space. So, and real space prototype in the virtual world, the simulated world. So all these require these analysis of spatial interactions between human and object and between object and objects. If you like math, first thing you need to know is math, and definitely I do a lot of physics. And more recently, I work on a lot of data, like medical data, traffic data. And so statistics really helps because we are looking more and more into these data-driven approach. That means that we will use more and more statistical methods. We are also doing a lot more machine learning, deep learning type of work with application to these different domains. And so, statistical knowledge, probability, those are really, really critical also. And we are finding them to be, an increasing part of our research. Most of my students are PhD students, so many of them have gone on to be professors elsewhere. And I have students who are professors at University of Minnesota, Twin Cities. I have students who are at University of Michigan. I have students who is professors at University of California, Santa Barbara. But I also have students who are working in places like Google, Microsoft, Pixar, and Apple, and different research lab across the countries. And I even have students who started their own company. Their PhD dissertation was such a groundbreaking piece, so they started with their own company. and they are trying to get their stuff out. When I say I work in multimodal interaction, that including interaction technique that would involve audio, sounds, also touch-enabled interfaces. I have students who are all working in all these different areas, so they are working across just all different companies, university, and they are having a lot of fun. So here is the way I see computing, okay? I see computing, it's not some specialty field. If you look around us today, literally look around us today, everything that we do involves computers. From as simple as the moment you wake up in the morning, when you pick up your cell phone or your mobile phone, that is a computer, okay? When you text your friend on a social network, you are doing computing, okay? You are using computing technology, interacting with your friends, with your family, with the world. And computing today, it's no longer a specialty. It is part of our daily life. And everything we do is involving some form of computing, one way or the other. And I would love to see computing to be part of our regular curriculum from kindergarten through high school, because I see computing to be so prevalent everywhere, from cell phone to your laptop, to everything else as you do, like ATM, just withdrawing money, even going shopping, buying clothes online. I mean, you name it, it's everywhere. Curing cancers, developing new drugs, planning a new city, traveling the world. I mean, think about what you do, it doesn't involve computing. Everything that we do involves computing, even music, digital music. The song you listen to has already been processed by computer. So as a society, we need to have that knowledge, and it should be embedded in our curriculum from day one. Now, you can still do everything else you love, but having that knowledge is going to help you and enable you to do whatever you love better, either as a career or just as something that you have learned through your school classes. So that's how I see computing.